A 25 centimeter cube sample of 0.620 mole per decimeter cube nitric acid was placed in a beaker and 38.2 centimeters cubed of a 0.550 mole per decimeter cubed aqueous sodium hydroxide were added. Calculate the pH of the solution form. The ionic product of water Kw is 1.00 times 10 to the minus 14 mole to DM minus 6 at 25 degrees Celsius. So this is also a 6-mark question. It's very similar to the buffer solution question, but instead of Ka we're given Kw, and this is basically just an acid-base reaction, so it's not a buffer solution, but the calculation is essentially the same. So just finding the H plus ion concentration and then substituting into the Kw equation. And I feel as though this one's a bit easier because you're working with less numbers basically. So first, obviously calculating the moles of nitric acid, so moles of nitric acid, HNO3, and that's equal to 0.620 times your volume divided by 1000 to get in moles per decimeter cubed, because we're doing this converting the units. So 25 divided by 1000, and that gives us 0.0155. And then we can calculate the moles of sodium hydroxide, NaOH, and that's equal to 0.550 times the volume, which is 38.2, divided by 1000, which gives us 0.0201 to 101, sorry. And notice we have an excess of sodium hydroxide, so moles of NaOH in excess, again abbreviated, and that's equal to 0.02101 minus 0.0155, and that gives us 5.51 times 10 to the minus 3. And this is basically our hydroxide ion. So now what we can do is calculate the concentrations of each of these. So the concentration of OH, or hydroxide, is the excess of NaOH, so that's 5.51 times 10 to the minus 3, divided by the total volume now, which is 25 plus 38.2, which gives us 63.2, divided by 1000 over 1000. Again, we want it in decimeters, and we're given it in centimeters. So remember total volume, so add the two volumes up, and that gives us 0.0872. And now simply substituting into the equation, so Kw is equal to our hydrogen ion concentration multiplied by our OH minus, or hydroxide ion. So to get H plus is equal to, H plus concentration is equal to Kw over OH hydroxide ion concentration, and then putting the numbers in we get 1.00 times 10 to the minus 14, all divided by 0.0872, and that gives us 1.147 times 10 to the minus 13, and we know how to calculate pH, so just taking the negative log of our hydrogen ion concentration, and that gives us 12.94. So a bit simpler than the Ka type, I think. It's still worth 6 marks, so hopefully we get this in the exam. Yeah, so thanks for watching, and I'll see you again soon.